Welcome on this tutorial. On this tutorial, we are going to discuss projectile motion. Projectile motion is two-dimensional motion. The two dimensions are the horizontal motion with constant velocity and the vertical motion with constant acceleration due to gravity. Projectile motion can also express in free fall. It can be analyzed by applying the particle under constant velocity in the horizontal direction, where the horizontal displacement x is equal to the initial displacement in the x naught plus uxg, where ux is the velocity in the x-axis and g is the time taken. The particle under constant acceleration in the vertical direction with x change to y and a y equals minus 9.8 meter per second square. These are the uniformly accelerated motion equation in the vertical direction. The velocity at any time, the average velocity, the displacement, all these equations are given. Note, acceleration in the y is minus 9.8 meter per second square because of always negative. The velocity and the way up is positive and the way down is negative, and take initial displacement at the ground equals 0. Take acceleration in the y equals minus 9.8 meter per second square or minus 10 meter per second square, and the velocity in the way up is positive and in the way down is negative, and the initial displacement in the y-axis at the ground equals 0. Here is the two balls, the red ball and the yellow ball. The two balls are initially at rest. The yellow ball is projected horizontally at the time of the red ball is dropped from the same height. Both balls strike the ground at the same time. The time taken by two balls depend only the height of the building. Here is an example. A tennis ball machine fires a ball vertically upward at a time t equals 0 and the initial velocity 19.6 meter per second. Assume that the air resistance is negligible and take gravity minus 8 meter per second square. Calculate the displacement and the velocity of the ball at 1 second, 2 seconds, 3 seconds and 4 seconds. B. Use our answer to part A and draw the graph of displacement against time for the ball and the graph of velocity against time for the ball. The solution is, using this equation, the displacement in the vertical at any time y is equal to y naught plus v initial y t plus half a y t square, and ay is minus 9.8 meter per second square, and the initial velocity in the y is 19.6 meter per second, is positive upward, and the velocity at any time equals the initial velocity in the y plus acceleration in the y times t. At 1 second, when substitute, the initial velocity is 19.6 meter per second and the acceleration due to gravity minus 9.8 meter per second square times 1 second, it gives 9.8 meter per second. The motion is upward because of the velocity is positive, and the displacement at 1 second equals the initial displacement plus initial velocity t plus half ay t square. The initial displacement is 0, the initial velocity is 19.6 meters per second, and the time is 1 second minus 1 over 2 times 9.8 meters per second times 1 second, it gives 14.7 meters. The remaining is the same calculation for 2 seconds, 3 seconds and 4 seconds. We are going to get the results. At t0, the velocity 19.6 and the position is 0 since at the ground. At t1, the velocity is 9.8, the position is 14.7 since the velocity is positive, it's moving upward. At t2, the velocity is 0 and the position is 19.6 since the velocity 0, the object reaches at the maximum height. The maximum height at 2 seconds is 19.6. At 3, the velocity is minus 9.8 and the position is 14.7. The negative sign indicates the object come to its starting point, or the object changes its direction. At t4, the velocity is minus 19.6 and the position is 14.7. The position is 0. The object at t4 comes to its starting point since the velocity in magnitude is the same with initial velocity and the position is 0. It comes to the ground. Here is the velocity versus time graph. The velocity versus time graph. At t0, the velocity is 19.6. At t1, the velocity is 9.8. At t2, the velocity is 0, reaches at the maximum height. At t3, the velocity is minus 9.8. At t3, the velocity is minus 9.8. Changes the direction. At t4, the velocity is minus 19.6. It comes to the starting point or throwing point. Here is the position versus time graph. At t0, the position is 0. At t1, the position is 14.7 meters. At t2, the position is 19.6 since it reaches at the maximum height. At t3, the position back to 14.7. At t4, the position is 0. It comes to this throwing point. Thank you for watching. Please subscribe to get more tutorial.